try to understand, guys, one thing over there. So we have a two branch office. Okay. Guys, we have a two branch. We have a Cisco Delhi, right? So the one company we have a Cisco, right? And Cisco has a two branch office, right? One we have a Bangalore location and one we have a Delhi location. 1 minute. Okay. At the same time, we have another branch location. We have a Nokia, right? So this is the Nokia company, and Nokia has a two branch office. One we have in the Bangalore location, and one we have in the Delhi location. Now, try to understand if I want to just provide the communication between these two guys, right? I want to provide the communication between this subnet 1.0.0/8 to this guy 3.0.0/8. What happened? I need to take a help of the ISP, right? I need to take a help of the ISP. Same thing. What happened if you want to provide the communication between these two subnets, right? 2.0.0 Nokia Bangalore and Nokia Delhi. What happened? I need to take a help of the ISP. So it doesn't matter, right? It doesn't matter if you're going to provide the communication between the one office to the another branch, right? One location to another location, and one location to another location. Even the between the companies, we need to take a help of the ISP. There's no right now. There's no problem in this connection, right? In this setup, there is no problem. Of course, we need to take a help of the ISP, right, to provide the communication. But try to understand what happened. Try to understand what happened. What I'm saying that I want to secure, or not secure. I want to just exchange this information only to the Cisco, right? This is the upside is running with the Cisco company, right? This router on number one is Cisco, and this router number two is Cisco Bangalore, and we have a Cisco Delhi. Same thing, we have a Nokia Delhi, and we have a Nokia Bangalore, right? If you want to exchange this information 1.0.0/8 from Cisco Bangalore to the Cisco Delhi, you need to take a help of the ISP, right? But the problem is that I'm setting my all LAN information to whom? The router number one, that is the Cisco, is setting the LAN information to the ISP. Same thing, the Cisco Delhi is going to share the own LAN information to the ISP. And Nokia is going to share the own LAN information to the ISP, and also same way this guy as well as. So whatever the routes they have, they need to exchange this information to the ISP. Right? That's good. Because I'm taking connection with the ISP, I need to exchange my information. But take example, what happened if this person is going to run with the ESGRP routing protocol, any of the routing protocol. In this case, what happened? I need to share this information to the ISP, or what ISP is going to do in this case. ISP is also going to share this information to the Nokia branch. This ISP is also going to share this information to the home, Nokia Delhi, right? And if they have another company, Accenture, right? Take example, this is a router number 6. This guy is Accenture. So now this information 1.0.0 information that is coming from the Cisco LAN office, this information also extends to the Accenture as well as. At the same time, if you have a different company, for example, Microsoft, so you're going to share this information 1.0.0 that belongs to the Cisco. You're also going to share this information to the Microsoft. ISP is what? ISP is a public network, right? On a public, what happened? We have some good user and we have some bad user. On a public, what happened? We have some good user or bad user as well as. What I want in my case, I want, like, if I'm going to share this information is only access to whom? Not to the this guy, not to the this guy, not to the this guy, not to the this guy. What I can do in this case, I can do one thing. I can inform to the ISP, hey ISP, do one thing, just give me the one separate infrastructure. Just give me the one separate infrastructure. And same way, Nokia is going to say that, hey, just give me the one separate infrastructure to me as well, as because I cannot share this information, my own LAN information, to the any other person. What happens? Cisco is saying that, hey, just give me the one separate infrastructure so that I can share the own information to the only the own branch office. And Nokia is saying that, hey, just give me the one separate infrastructure so that I can share the own information to the only own branch office. So what ISP is doing? ISP is like, okay, let's do one thing. Take it the one separate infrastructure, right? But what is the problem is happening in this case? Cost. And what do you think? Is it a scalable solution? No. The first problem is that I need to exchange, right? I need to exchange this information 100.0.0 only to the Cisco Delhi, right? I need to exchange the Nokia Bangalore office information to the only Nokia Delhi office, right? In that case, what happened? We need to take a separate infrastructure. Again, in the separate infrastructure, what happened? We need to implement the cost over there, and this is not a scalable solution. Because normally what happened, if you're not going to use, right? If I'm not going to use this solution, right, separate infrastructure, in that case, what happened? Router 5 is going to maintain the global routing table because EIGRP is running over there, and this router number 5 is going to maintain the global routing table. So whatever the information is coming to me, I can save this information to this person, and this person, as well as to every person. If you have a thousands of the company that is associated with the ISP, all the thousands of the company will receive this information. All the thousands of the company will receive Nokia branch information. And do you know one thing? If the any bad user are present over there, if the bad user will get the idea about this network, right, 4.0 and 2.0, the LAN information, they can perform any kind of attack. They can do the DOS attack as well as they can deny your services if they know about your network. You are sharing, right? The customer is sharing the information to the ISP. Why? Because they need a connectivity. Why should I share my own information to the different company? Listen to me. Why should I share my own information different to the company? It is something like this. There's a person over there. This person name is ABC, and his contact number 123. His age is what, 49. He's belong to the, like, the Bangalore HSR layout. So he can share the own information to whom? The government authority, right? Government official. But they cannot share this information to the any other guy. This guy cannot share their own information to any other guy, right? But they can share the own information to the government. Same thing happened with this case. I can share, I need to share my own information to the ISP, right? But I cannot share own information to the different companies. I can only share my own information to the own branch location, not to the different company. If the different company will get the idea, for example, if the R2 will have an idea about the 1.0.0 and 3.0.0.0 that's associated with the Cisco, the Nokia users, right, can perform an attack in their network. They can do anything, right? They can perform the DOS. Or DOS means what? Denial of service attack. They can deny your services, right? So to avoid this problem, what happened? We can do the separate infrastructure, but in the separate infrastructure, what happened? The cost, and that is not a scalable solution. So to avoid this solution, what we can do over there, we can segregate your routing table. Segregate. with companies. For example, I can say on the router number 5 right now, how many routing tables they have on the router number 5. On the router number 5 right now, what happened? We have this routing table, the global routing table. Why I'm saying this is a global routing table? Because this routing table is going to maintain the info of the all the customer by default. By default means what? If the R1 is going to share this information, I can put this information into the this one. It is something like 1 minute. Let's do like this. This guy R1 is going to share the own information to the this routing table. R2 is going to share the own information to the this routing table. R3 is going to share the this information to this routing table, and R4 is going to share this information to this routing table. And whatever the companies you have, if you have a 1,000 company, take example, all this 1,000 company is going to share this information to the global routing table. So what I'm going to do, I am just going to segregate, right? I'm just going to segregate this routing table. How do I do that? I just said that let's do one thing. I'm going to segregate this routing table into this section, okay, and this section. Like this, we can do that. This one and this one. And I can say that, okay, this portion is belong to the home. This portion is going to belong to the Cisco. This portion is going to belong to the Nokia, and remaining portion belong to the global. So whatever the route that is coming from the Cisco, it only is stored in the Cisco information, right? For example, 1.0.0.0, 2.0, 3.0.0.0. It's only present in the Cisco. The Nokia information is only present in the Nokia. This guy, 2.0.0 and 4.0.0. And the global is only present in the global. What are the globals we have? Remaining route that is coming from the different companies. So all this information, right? All this information, what is the information that belongs to the Cisco? Cisco, I'm going to put in the Cisco routing table. I'm going to put the Nokia information in the Nokia routing table. And the remaining route will be put in the global routing table. I'm going to segregate my routing table information. It is something like that. We are going to segregate our layer 3 information by using a VRF. By using a VRF, we are going to segregate our routing table. It is same like your VLAN, guys. Ditto like your VLAN. What VLAN is doing over there? It's segregating your MAC address table, right? Every VLAN, for example, this is the one MAC table for the VLAN number 10. This is the one MAC table for the VLAN number 20, and this is the one MAC table for the VLAN number 30, right? So MAC table for the VLAN number 10, MAC table for the VLAN number 20, and MAC table for the VLAN number 30. So we are doing VLAN. Why? to just segregate our MAC address table. Same thing, what we are going to do, we are going to do the VRF to segregate our routing table information. So what VRF is going to do, VRF is going to create a logical routing table. Same like your VLAN 10 is what they are doing. They are going to create a separate logical MAC table, separate logical MAC table, and separate logical MAC table. Same way, by using a VRF, what I can do, I'm going to segregate the routing table information. How do I create the VRF on the router side? The first thing, how do I create the VLAN? We just need to go on the router, sorry, switcher side. I need to put the command VLAN number 10, right? What this command is going to do? This command create the VLAN. On a VRF side, I just need to say that IP. IP means what? I'm doing the configuration for the IP protocol. That IP protocol can be IPv4 and IPv6 as well as. So I need to define the IP, and then after that, I need to define the VRF, the keyword that I'm going to create a virtual routing table, and the name of the virtual routing table will be Cisco. You can take any name, it's totally up to you guys. You can take the Cisco 123, you can take the Cisco 1, you can take the 123, whatever you want. It's just a name of the table, of the routing table name. This is the name of the routing table. And after that, I say the exit over there. That's it. Same way, IP VRF table, Nokia. Depend on the name of the company, I'm going to create the routing table. If you just have a look, let me see, can get the IP 192.1.31, right? One 98. If you see right now, I'll show you this thing. By default, on a switch side, what happened? We have a single MAC table, right? Depend on the VLAN, because by default they have a single VLAN. So you can correlate each and every words of the VRF with the VLAN, every single things. So if you see show MAC address table, what happened? I have a single MAC address table, right? I have a single MAC address table. What I'm going to do, I see the VLAN number 10, VLAN number 20, 30. Show MAC address table count. 1 minute. And you associate this. You see what happened? So we have a separate MAC table for what? Separate MAC table for what? Same thing, guys, we are going to do with the VRF. The global routing table will be divided into the Cisco routing table, Nokia routing table, and the remaining global routing table. I'm going to divide the one routing table. It is something like that. By using the VRF, this is the one routing table. This one routing table will be divided into the three sections. Whatever the depend on the requirement, right? So this is the Cisco routing table, this is a Nokia, and this is the global. So I'm going to make a partition of the routing table. And this routing table will be a virtual routing table. That's as the virtual means what? VRF. V4 virtual. And based on this routing table, I'm going to forward the packet. That's the meaning of VRF. Virtual means what? This is percent. Sorry, this is you can see that, but actually this is not percent, right? Routing means what? Based on the in this routing table, I'm going to store the route information. Forwarding means what? Based on this virtual table, I can forward the packet. Or I just need to create the VRF. How do I do that? I just need to go in the global configuration mode like that VLAN 10 to make an identifier of the VLAN, the MAC address table. To identify the routing table, we need to put the name of that. To identify the routing table, same like VLAN ID. So what I'm going to do, guys, try to understand this part. If you just go open the router number 5 right now, the ISP that I have. Router number 5, and let's see the prediction of the so IP interface brief. You see, all I have IP addressing, right? And if you see right now, information is present in which table?
Your voice is breaking, sir. We can barely hear you. We cannot hear you.
One minute, guys. Take a minute. I need to check. I think so. Take a minute. Info security to so there's a perfect. That's clear. So what I'm going to do on a router of 5, guys, if you just have a look right now, all this information is present in the global routing table, right? Every single information is present in my global routing table. And if you see where the verify the router 1 configuration right now, this router 1, 2, 3, and 4, all they have a proper IP addressing, right?
Can you show the config, sir? Pre-config.
Yeah, I'll show you 1 minute. If you see the router 1 configuration, show IP interface brief. Router number 1, right? On a router number 2, if you see the Nokia Bangalore, right? This office. If you just go back to the router number 3, that's a Cisco Delhi. And if you go back to the router number 4, Cisco Nokia Bangalore. Sorry, Nokia Delhi, this information.
And what's the AGRP configuration, sir? You've done AGRP on it?
No, nothing I'm configuring right now. Nothing. I'm just going the IP addressing information right now.
Oh, okay. And on R5, then how are the routes visible, sir? Is there?
So if you see the R5 is going to maintain all this IP addressing, right? And all this information is put in my routing table. So if you run any of the routing table right now, just try to understand this part. If I'm just provide the reachability, router EHRP number 1, right, as a network 0.0.0. Take example right now. I'm just trying to show you the problem. I'm just going to advertise all the route, right? And R5. What happened in this case? R5 is going to form the 4 neighborship. 1, this guy, 2, 3, 4. And what happened? Try to understand. R1 is now able to share this information to the R3. They belong to the same company, right? At the same time, what happened? R1 is going to share the own information to the Nokia as well as, can you see? So Nokia, this Nokia branch office, right, R2 is having an information of the Cisco. So if they wants to perform an attack, they can do attack any. They can do the denial of service attack. They can deny any of the services, right? That's belong to this subnet. We need to avoid this problem. What I want, this information will never exchange to this person. I only want to exchange my own information to this guy to this guy only, right? Separate infrastructure. I want to only exchange this information to this guy only, separate infrastructure for this guy. They cannot leak their information. For that thing, we need to segregate our routing table. I'm going to make one separate routing table for the Cisco, one separate routing table for the Nokia. So in this Cisco routing table, you only have this information, Cisco information, 15.0 and In this Nokia information, we can use the two different. So tell me if you have a 1 lakh, or not 1 lakh, 70,000 companies. Forget the 70,000 company. If you have 40 companies, how many EHRP you are going to run? How many EHRP you are going to run? Do you know the problems? See the problem. I'll show 1 minute. Give me 1 minute. I'll show you the problem. Hope if you remember this part. Swami, did you remember this part? What was that?
Yes, yes. I think I
What was
can't
that?
remember the number exactly, but it kind of throws an error after.
How much?
Is it 30, sir? I can't remember. 15, 30.
Ron does not have an idea of this. Twenty-four? No, 24, not 24. It should be 20, 31 or 32. 30. Devendra, you got the answer.
Yes.
अब मैं इसको रीस्टार्ट मान लेता हूँ. नहीं तो ये फालतू में ना मुझे पूरा हटाना पड़ेगा. Stop. Stop. Right. So basically, what happened? You can see that R2 is able to listen this all information, right? That I don't want. Why should I share my own information to you, right? Why should I share my own information to you? It's totally illogical. Second thing, is that, you know one thing, try to, and what we are doing, we are just avoiding the separate infrastructure problem, guys. Try to understand. VRF is just avoiding the separate infrastructure problem. Otherwise, what happened? You need to implement the physical router over there. If you're not going to use the VRF, you need to install the physical router on this guy and this guy. And if you have 1,000 company, you need to implement the ISP is going to implement the 1,000 separate router for each company. That's not possible, right? For 1,000 company, you need to regard the 1,000 order. If you have 2,000 company, you need to regard the 2,000 order. Never possible. Not possible even. So that's why we introduced the VRF. And do you know another reason? See, what is the RFC 1918 say that? Public and private address. The private address can be duplicate, right? So look, get duplicate. Cisco is going to use the 10.0.0 subnet, and this Nokia is also going to use the 10.0.0 subnet. Which information R5 will install? The ISP router. If the router of 5 is going to have a one routing table, which information they will store? 10 from this side or 10 from this side? If the metric will be same, both information, load balancing. So if this user will send a packet to the Cisco, what happened? This packet is also coming to the Nokia. एक मिनट देना. So what happened in RFC 1980? Private address can be duplicate. Low ho gaya, load balancing karo. The PC wants to send a packet to the what 10 or 10 or 10 or 10. When this packet is coming to the ISP, what ISP is going to do? To this one and this one. This kind of problem also will be avoided by the VRF. How? I'm going to make a Cisco routing table over there, and I'm going to make a Nokia routing table. So this information 10.0 is coming to the Cisco. Bol. पास पास क्या? हम बोल रहे मैं सुन रहा हूँ. R G R proxy R ये सब पढ़ना है. कब पढ़ना है? आज ही. क्यों? DHCP खत्म कर दिया. कल दूं? कल. बेसिक आर्क तो कल एक लेक्चर में पढ़ाया था. कल 3 घंटे का लेक्चर लिया था सब का. ठीक है. 3 घंटे सिर्फ आर्क कर लिया था. ग्रेटिट्यूड आर्क तो दूर की बात है अभी. ठीक है. सो एक काम कर, मैं तुझे बैच कर देता हूँ. ठीक है, मिलता हूँ. बैच कर जाना 1 बजे आ जाना. 1 बजे पक्का टाइम से 1 बजे आना, तो मैं निकल लूंगा 1 बजे. हाँ 1 बजे पक्का. 12:50 पे. हाँ 12:50. ओके डन. So what we can do, guys, with the VRF, we can segregate our routing table. So now in the Cisco, I'm going to maintain the 10.0.0, and Nokia, I'm going to maintain the 10.0.0. So if this user will send any packet, what happened? If this user will send a packet from the Cisco, it only listen by the Cisco routing table. If the user will send the packet to the Nokia, it only listen by the Nokia routing table. So now there is no chance of, the like a packet, the snipping of the packet. There's no chance. No one can see your packet, and you can done with the VRF. How do I create the VRF? The first thing, right? How do I create the VRF? Same concept like a VLAN, right? If you have a knowledge of the VLAN, this VRF concept is become very, very easy. How do I create the VLAN? You just need to go on the config terminal, VLAN number 10, VLAN number 20, and like this, right? Same way, I need to get the IP VRF Cisco, IP VRF Nokia. So right now, if you just have a look right now on router number 5, I don't have any VRF, right? If you see, I don't have nothing. I just have a routing table. In my routing table, I just have a route information. What I'm going to do, I just need to say that debug IP routing, IP VRF. What? Define the name. Cisco. What happened? Routing table Cisco has created, right? How many tables we have right now? 2 active tables. One is a global routing table, and one is a Cisco routing table. What is a global routing table? That they have a routes over there, and one is the Cisco routing table. Same thing, I need to create the another routing table, VIP VRF Nokia. Now 3 routing tables we have. This is just a name, and this name is, guys, this name is a case sensitive. I'm telling you, many person is doing the mistake in exam just of the name of the VRF. Many person. Once we have done with this part, what we are doing in the VLAN. Once we have done the VLAN number 10, 30, 20, IP VRF Cisco, and IP VRF Nokia, what we are doing after that? In the VLAN, you need to say that interface 0/0 switch port access VLAN number 10, right? Same thing in the VLAN of 30 switch port X interface 0/0. Same way, what I'm going to do. How many interface that is belong to the Nokia right now? How many interface that is belong to the Nokia? See this topology, right? On this ISP at this interface, right? 1/0 and this 2/0 is belong to the which person? Nokia. And this 2 interface is belong to whom? Cisco. So what I'm going to do under this interface, right? Interface 0/0. I need to tell this person, hey, this interface is now going to be part of VRF. Which person? This interface is now going to forward the packet, right? This interface is now going to forward the packet based on the Cisco routing table. Same way, this interface is now going to forward the packet based on the Cisco routing table. This interface 1/0 is now going to forward the packet based on what? This interface. I'm done. So now what happened after that? Try to understand this part. If I'm going to put this command, try to understand, copy, whatever the IP address is associated with this interface, right? 0/0, automatically they will remove from the interface and they remove that routes from the routing table as well as. So read this line, interface fast Ethernet 0/0 that I called in the VRF forwarding Cisco. So this interface 0/0 IP address 15.5 is removed due to the enabling the VRF Cisco. Now this interface is the part of Cisco. And now I need to define the IP address. So right now, if you just have a look right now, 1 minute, do show IP VRF. Can you see in the VRF Cisco, I have this interface. Do we have an IP address on this interface right now? No. I need to assign the IP address, right? So interface 0/0 IP address will be what? Once I'm going to assign this interface, what happened? In the routing table Cisco, this route will be added. In the routing table of Cisco, this route will be added. Same way, what I can do, I see that interface 0/1, this guy, right? IP we are forwarding what? Cisco. IP address.
Sir, you have to assign the IP addresses again, is it?
Of course, if the IP address has removed now. See, read this line.
Oh, okay. So it all got removed when we enabled.
Yeah.
Okay, okay.
Oh, you put 192.68.
Oh, sorry. I can do also like this, I can do also like this. In exam, you have to do like this configuration of the VRF. Do show run interface 1/0. This 1/0. What I can do, I know the IP address of this person 1/0 is 25.5. Interface 1/0. IP VRF forwarding Nokia, right? The IP will be removed from this interface, and then just need to copy. And you have to do like this step in the exam, because in exam what happened? In exam what happened? You will this thing will be not written right this way. I think so. It's written. I'm not 100% sure. This portion is written, but they are configured with the /36. So most of the time, what happened? The engineers get confused. If they don't have a good submitting skill, they will get confused over there, right? So you can do one thing whenever you're assigning the IP in a VRF. First, make that do show run section interface. Then put the IP VRF forwarding Nokia, and just copy this IP address and paste it over there. So there is no chance of error over there in this case. There is no chance of error. Same way, what I can do now, this interface 2/0 IPVR forwarding, just make it a do show run, right? Now I say the IPVR forwarding what? Nokia. Copy this guy. That's it. So now if you see do show IP interface brief, I all have IP addresses, but this IP interface is belong to the which part? VRF. Cisco 0/0, 0/1, Nokia 1/0, and 2/0. If you just have a look at do show IP route, this command, it will show you the global routing table. Do we have any information in the global routing table? No, because now this route is also this interface IPs route is associated with the particular routing table. So do show IP route VRF Cisco, my Cisco routing table. They have this information 35.0 and 35.0, 15.0 and 35.0. And if you check the do show IP routing table, says Nokia 25 and 45. All good. So can you see that I'm not going to leak the information? The routing table Cisco has a separate information, and routing table Nokia has a separate information. Now tell me one thing. If I'm going to create a one loop back, interface loop back number 1, IP address 5.5.5.5.5.5, on which routing table this router will be added?
Global.
Global. Do show IP route. Can you see? So this is how you can verify the VRF. So IP VRF, you see this command is going to tell you how many VRF that you have created and how many interface that is associated with the particular VRF. Show IP route VRF. This is the command to check the VRF routing table. Cisco. What is this guy saying that? Case sensitive, right? So make sure that if you putting the wrong VRF information, right? Sorry, wrong name of the VRF, they will not going to show you any output. This is the small things that you always remember. If you are troubleshooting of the VRF, make sure that your name should be correct. If your name is not correct, what happened? You are not able to achieve any single output. The name should be seen. Show IP, VRF. Okay, these are the information that's belong to the the MPLS part that I'm not going to discuss right now. So in the Cisco, we have these two things. So connected address are not in the global routing table. This part I'm going to discuss later on. Don't worry. What is the default RD, VPN ID, this concept in the MPLS part. Show IP VRF. What Cisco? So brief command, same information. Show IP VRF ID. Which ID is this one? VPN ID is talking interface. So these are the commands of the verification, right? So IP VRF interface. So these two interfaces right now, it's not a part of the global routing. Can you see it's also written over the connected address are not in the global routing table. Which interface? This interface. Now because they are associated with the which routing table now? Same way. Hope this thing is clear to all of you guys. Sorry. Anyone has any questions? Till this point, any questions till the configuration point of view? So how do I create the VRF and interface? No? It's clear, right? Now let's do one thing. Let's perform the routing on the VRF side. You can achieve the routing in the two ways, as we know that we have a static routing and when we have a dynamic routing. In a static routing, what happened? You need to define each and everything manually. That we know that, right? And dynamic routing, what happened? We need to use some protocol. Protocol could be HGRP, OSPF, BGP. RIP you can also use. Let's see the how we can define the static routing. So what happened? I just need to provide the communication between these two subnets, right? This guy to this guy right now. And let's do one thing. Also, I'm going to create the one loop back. This should be duplicate, right? So that we can easily achieve the beauty of the VRF, right? Interface loop back now 2, 10 or 10 or 10 or 10. So this IP will be duplicate on the Cisco Bangalore and in Nokia as well as Nokia. Interface loop back number 2. Same IP. What I'm going to do on a R1, right? How many network instrument I need to define? On a R1, I need to define the IP route. I want to provide the communication 35.0, right? Next up will be from R1. If you know provide the communication between these two subnet, right? First, I need to define the path for this person and then this person, right? IP route. Done. All good, right? Same thing from R3. On R3, how many paths I need to define? This guy, this guy, this guy. IP route. IP route. IP route. Done. Same way, this client R2. Normal static routing you need to do on the client side. IP route. So now R2, we need to define this path, right? There's two guys, right? 45 and 4.
Sir, but they are in that VRF routing table, right? This route,
Sorry.
no?
On the customer side, we are not doing the VRF.
Okay, okay.
Customer side, we are not doing the VRF, right? R3, sorry, R4. On R4, we need to define this path, right? This one, this one, this one. That. What about the ISP now? On an ISP, we need to define this path, this path. If you're going to put this command IP route, what happened? Tell me, if I'm going to put this command, what happened on the router on 5? Will this router on 5 is able to install this route in the routing table?
No,
Why?
because IP route 1.0.0.0 15.
Global routing table. Of course, they will install this route in the global routing table, right? That's the default because this command is going to tell you, hey, you need to install this route in the global routing table. My question is that will router 5 install this route in the global routing any routing table, not the global, any of the routing table? See, is any debug is happening? I don't have this route in the global routing table. Anyone tell me the answer of this question? Why?
Actually, it will not see the nest hop interface.
Exactly right.
And
This next hop is not reachable. From the global routing table, this next hop is not reachable. That's why I'm not able to put this route in the global routing table. Because this interface, this subnet is a part of which routing table right now? This interface, VRF Cisco. And where are you defining the route? In the global routing table. So in this global routing table, can I reach this person from the global routing table 15.1? No. See, I cannot reach from the global. Because this interface is the part of Cisco, right? So reachability must be there of the next hop. I cannot reach. I cannot put this route in the routing. So I need to define this path in the VRF routing table. How do I do the IP route VRF, right? Which VRF? Done. Same way, Nokia. $20.0. $45.4, right? Now you can check your routing table information. Do show IP route VRF Cisco. I have all this information and do show IP route VRF. See the beauty. Okay, 1 minute, 1 minute, 1 minute. About 10 or 10, 10, right? Not the 5, 20. See the beauty. This is the beauty of VRF. Segregate your routing table information. Two different routing tables.
Can you just do show IP route VRF Nokia and VRF Cisco, sir, once without the static? So it is showing that 45 and 25 was.
I'll put this screenshot 1 minute. I'll put this screenshot. You can verify this thing. So, same way we have a global routing for the global MAC table for the MAC VLAN 1, MAC VLAN 10, MAC VLAN 20, and MAC VLAN 30, right? Same way. Okay. एक मिनट मैं इसको हटा दूं quotes. I'll just remove this quote, right? Because this quote is taking some space. See, so I'll remove this quote. See, now let me know if you have any questions. The beauty. Beauty. You know, right on the command, I can see post the command as well as. So I can start a configuration. So this is the configurations, right? And this is the Swami clear?
Yes, sir. Yes.
Now understand the flow. Try to understand if I'm going to ping from R1, right? Actually, the source will be what? 1.101, destination will be 3.3.3.3.3.3.3. When this packet is coming to the router number 1, what router 1 is going to do? Behavior of the router 1, always perform the destination lookup in the routing table. Do we have a 3.3.3.3? According to my routing table, yes. I need to forward the packet to whom? 15.5. Again, what happened? It will perform the recursive lookup for the 15.5. Hey, where's the 15.5 is located? The 15.5 is located via which interface? This interface. The router 1 is going to perform the recursive lookup, and based on that, it will forward the packet to whom? 15.5 from this interface, right? R5 will receive this packet on which interface? 0/0, right? 0/0 is the part of which VRF. Cisco, right? So what happened? Instead of looking the global routing table, now this person is going to look up the VRF routing table. Routing table Cisco, and now I need to forward the packet to the 35.3. Where is the 35.3 is located? I mean, which interface? Not in the global routing table, so IP root VRF Cisco. 35.3 is located by the 0/1, and 0/1 is the part of which VRF? Cisco. So now it will forward the packet to whom? R3. R3 will receive this packet and it will create the reply packet, right? Reply packet will be source will be what? 3.3.3.3.3 and destination is 1.1.1, right? It will forward the packet by looking the destination lookup, right? R5 will receive this packet on this interface 0/1. 0/1 is the part of which VRF Cisco. By looking the Cisco routing table, I need to forward the packet to the home 15.1. Again, perform the recursive lookup. I need to use this interface to forward the packet. This is how your VRF, right? Your VRF routing table is going to interact with the packet. So now if you see on a R1, I can ping this person, right? Ping source to ping, right? All my packet is being forwarded by the VRF routing table. Router 5 is being forwarded this packet via the R5 VRF routing table, not the global routing table. Same way, if you're not ping, good to go. If you're not ping from here to here from this client, take example R3, I'm pinging whom? 10 on 10 on 10. What do you think? This packet is coming to this person, not to the Nokia. Nokia also have same information, right? 10.0.0. But this packet is coming to the R3. Why? Because this packet is received by which interface? 0/1, and 0/1 is a part of which we are of Cisco. So it will look up the Cisco routing table, and based on the Cisco routing table, it will forward the packet to whom? 15.1. Not to the other person. Not to the other person. I need to forward the packet to the home Cisco routing table. Through the Cisco routing table, I need to forward the packet to the 10.0.0. This is how your VRF is going to work, guys.
Sir, 1 minute. So when you ping from R3, it will be received on R5, correct?
R5, which interface? 0/1, right?
Right.
And 0/1 is a part of which VRF?
Okay.
Cisco. So it will look up the Cisco routing table.
Okay, got it. So when you do not give the source, what will happen? So if you
Nothing
just
will happen. Nothing will. Source will be your exit interface, right? Always.
So will it ping still, right?
Yeah.
Because 15.1 is also part of VRF.
Yeah. It will ping. No issue. Any questions, anyone? Anyone has any question in the configuration line or anywhere? You can ask me to the configuration, right? IPv4 Cisco interface 0/0. Call this VRF. Same like a VLAN. Here the VLAN and call that interface into the VLAN.
And then you configure static routing basically to all the exit interfaces, correct?
Exactly in the sense, I didn't get your questions.
So you've configured static routing
Yeah.
Towards all the exit interfaces only, right? Towards like for 1.0, 15.
Next hop. Next hop. It's
Next hop, sorry.
You can use the exit interface as well as it's totally up to you. You can use the next hop as well as exit interface, or you can use the combination of as well as next hop and exit interface. It's like, you know, you have to configure yourself, right? This thing, right? Okay, I'm gonna use this thing, I'm gonna use this thing. The concept of VRF is simple, like segregate your routing table. So now the Cisco cannot communicate with the Nokia, and Nokia cannot communicate with the Cisco by default. If you know what, if you want to provide the communication with the some companies, for example, company A can communicate with the company B, but company B cannot communicate with the company C, you can do like this as well. Then you, in that case, you need to do the linking of the VRF route linking. But the default behavior is that they cannot communicate. Like in the VLAN, what happened? The VLAN 10 can communicate only with the VLAN number 10 user, right? They cannot communicate with the VLAN number 20 user. If you now provide the communication between the VLAN number 10 to 20, what happened? You need to create an inter-VLAN routing, right? Same way, you have to do VRF route linking. If you now perform the communications between two companies, or we can say between the two different VRF. Between the two different VRF, you know, provide the communication, you need to do the VRF route linking. That we'll discuss, don't worry. Okay. If you want to provide the communication between A to B, company A to the company B, same like a VLAN number 10 to 20, what happened? We need to do the inter VLAN routing. My concept is just right now giving the how to, like how to enable the VRF. That's it, right? Because the topic of the VPN part, right, is coming with some VRF concept. That's why I taught you the VRF. So don't worry, tomorrow I'm going to discuss about this VRF part, VRF with the dynamic routing protocols, right? And then I will teach you the VPN part, VPN with the VRF. How VPN with the VRF, then VPN with the IPsec is still pending, right? DM VPN over IPsec.
Dynamic is what will be on the lab, correct?
Yeah. Dynamic in the wrap.
What is VRF light, sir? Then
This is the VRF light.
oh, this is VRF light. Okay.
V dot. Sorry. Okay, author. चलो एक टास्क दो क्या चल लेट्स राइट ऑन दिस व्हाट इज फ्रंट वीआरएफ आ गया FVRF all good any questions anyone
Did you ever notice how you give these assignments and then you never follow up on them?
you did you have to inform me first of all right then I'm going to follow up with you you have to
You
inform
asked
me
this
right
you asked this about a month ago about
which task that I
overlay
asked that
versus underlay. And
so that overlay versus underlay I gave you the task that you need to find the difference between that this is the things that I'm going to cover in the,
I found it a month ago.
so that's the part is coming in the front VRF. That's a part of the front VRF, right? What is the difference between the overlay underlay? Sorry, what is the disadvantage of the overlay? That disadvantage will be overcome into the front VRF.
I'm just saying.
No issue, don't worry. Okay, I'll give you the one more task. Okay, don't worry. I just find the meaning of this person. T7. बता दो स्वामी क्या होता है? What is the meaning of T7? Okay, let me pause the recording. What is the meaning of T7, Swami?
T7.
What is that?
What is that?